variables. Okay, so we frequently use letters in mathematics because they allow us to calculate quantities using formulas over and over and over again. And what I mean by that is, if I know that every day or every time that I see grandma, I'm gonna get $5. $5 from grandma. Okay, and I know that, we'll say for every visit. And I know that I'm going to see grandma 4 times that month. Okay, I'm gonna see grandma 4 times. And then I know that it's also my birthday that month, and I'm gonna get $25 from grandma for my birthday. And that's going to be multiplied by how old I am. So this is a basic question that we'd have to make a formula out of. So the big thing to remember here is you're going to see her 4 times for sure. So that is going to be what we call a constant. So a number that's not going to change. Okay, and same here. I'm going to get $25 for sure, but multiplied by how old I am. Okay, so we know $25 is a constant. It's not going to change. And actually, I'm going to switch this up here. $5 from grandma every visit. And we don't know how many times she's visiting. So that changes from a number we know to a number we don't know, just like how old I am. Okay, so that means in this case, the $5 is going to be my constant value. So when I have something like this, I'm going to need something to represent what I don't know. And that's where a variable comes in. Okay? So for a question like this, I would actually look at something like, I get $5 from grandma for every time she visits. Let's say that the time she visits is equal to X. And add is add. I'm also going to get $25 multiplied by how old I am, and we'll maybe call that A for age. Okay, so then that would equal money that I'm going to get from grandma. Okay, so it's just remembering that if I just see an equation like this, the 5 and the 25 is something that's set in place, that's not going to change, while the X and the A are my variables that are something that will change. And this means, if this doesn't change from year to year, this means from my first birthday, let's say I saw grandma 7 times, so then my 7 would go where my X is, plus 25 times I'm 1 year old. Now, if nothing changes, when the next year, when I only see grandma 3 times, but I'm 2 years old, I can still find out how much money I'm going to get from grandma. Okay? So the common letters that we use for variables, I use a couple above. X. I used Y is another common one. T, R, V, and H. Okay, I also used A above. You can basically use whatever variable you would like to, as long as it makes sense, okay? And we call these letters variables because they can have different values. So like I showed you above, our X could be 3 or it could be 7. So that makes it a variable. And same with our A. 1 or 2, it's changing, so it's a variable. And again, let numbers like 3, 45, 19, above here, right? 25 we see, and 5. Those are what we call constants. and they can only be that number. We're not going to be changing that. Okay, so some steps to dealing with variables. 1, we want to write the equation out. We want to be able to see the equation. Okay, and most of the time we're going to get examples, and they're going to want to give us the value of 2 variables. It's not going to be quite like this question up here. This was a harder example that I gave just to try to explain things. But we're going to write down the equation so we can see it and give us space to work with it, okay? So the second step that I would say is we want to write in our variable values. So if the question gives us x is equal to 2, then every time that I see x, I want to write in a 2 in place of it. Our third step would be to do what we were doing above and take into account precedence. Okay, so adding any brackets you may need in to help you solve that question. And then 4, kind of along the same way, going over bedmiss and just solving the way that we need to. Okay, so we'll start with a quick, easy example. So we want to calculate the value of u plus a times t when u is equal to 2, a is equal to 4, and t is equal to 9. Okay, so the first step that I had said was write down the equation. U is, not equal, u plus at. Okay, my second step, if we look up here, write in the variable values. Okay, so I know u is equal to 2, so I can put in 2. A is equal to 4, I can put in 4. And I know this is a multiplication because I didn't see a sign here. And t is equal to 9. Okay, so now that I've written that in, we're going to check precedence. So bedmiss. These two steps here are kind of go hand in hand. They're kind of the same thing. So from there I know bedmiss. Brackets, none. So I'm going to probably add some in. Exponents, none. Division, multiplication's in there. So I can add in my brackets to tell me that's what I'm doing first. And then I'll add at the end. So that gives me 2 plus 4 times 9 is 36. And then I add, which gives me an answer of 38. Okay? Pretty straightforward. So let's do a couple more examples. We want to calculate the value of 2x plus 3y minus 4xy. And we want x to equal 5 and y to equal 2. Okay, so that's my question. So first step, write the equation out. 3y minus 4xy. Now, what do I notice here? Okay, so, first we want to put in those values. Almost forgot about that. So, I have 2. This is an x, which is 5, plus 3 times, nothing in between there, 3 times 2 minus 4 times 5 times 2. Okay, perfect. So let's check our precedence. I've got some brackets, so I'm going to grab those first. In this first bracket, I have 5 plus 3 times 2. I have some multiplication, so I'm going to do that first. 3 times 2 is 6. 5 plus 6 is equal to 11. Okay, so after that step, it's going to be 2 times 11 minus 4 times 5 times 2. And we can even get rid of these brackets and write times 11 to make it a little bit easier on ourselves. Okay, next. No more brackets, no more exponents, no division. Got a lot of multiplication in here. So if we start from the left, we have 2 times 11. We know that's going to happen first. Then on the right side, we have 4 times 5 and 5 times 2. And remember, it can happen kind of in any order. So we can do this one, and then we can do the big one. Okay? So then I have over here 2 times 11 is 22. And then over here I have 4 times 5 is 20. And 20 times 2 is equal to 40. So 40 in that brackets, which means that I end up after that step with 22 minus 40. And that should give us negative 18. Okay, so really straightforward following those. Okay, and then, yeah, before we can move on to fractions, we need to understand what a reciprocal of a number is. So that's what we're going to be moving on to next, is reciprocals. So the first thing to know about a reciprocal is a reciprocal of a number is 1 divided by the number. Okay, so the reciprocal of something like 6 is just 1 divided by 6. Just a fraction. And then we have this 45. Then the reciprocal of 45 is just 1 over 45. So then, knowing that, how would we write the reciprocal of a fraction or the reciprocal of a reciprocal? So what I mean when I say that is I want to write the reciprocal of 1 over 9. Okay, so this is like asking how many times does 1 over 9 divide into 1? Okay, so the reciprocal, if we go in above, is like this. That's how we learned it above. Okay, but that's not something we want to look at. That's kind of hard to look at. We don't fully understand it. So like I said, this is asking how many times does 1 over 9 divide into 1? And we know that is the answer, 9. Okay. Now, if we move on to another example, I have 1 over 6. And 1 over 6 ends up being 1 over 6, which ends up being 6. 8, 1 over 8, just stays 1 over 8. 1 over 20 ends up being 1 over 20, which is just 20. Okay, so by looking at these examples that we've done, specifically this one, and this one, what we can note here is anytime we have a fraction, it's just flipping. So this 9 is just like saying 9 over 1. This 6 is like saying 6 over 1, which is just the flipped version of 1 over 6. So we can see from these examples that the reciprocal of a fraction can be found just by flipping or inverting the fraction itself. Okay? So that is the basis of precedence, variables, and reciprocals, and we're going to get some more practice in before we call it a day. So I'm going to write down an equation like I've done in previous videos. I'm going to pause for a second to give you a chance to pause the video, try out a question on your own, and then I'm going to go through with how I would answer that question. Okay? So first, we'll label this more practice. Okay, so the first question I have for you is simplify and solve. So for all of these, we're going to simplify them and solve them. Okay, so for the first question in this portion, I have 4 times 3 plus 2 times 6 squared minus 2 times 7 times 3. So I'm pausing here. Remember, we want to think about BEDMAS. We want to think about all those precedence rules that we just talked about. Maybe you want to add in some brackets on your own before you go through, just to mark out what you need to do first. Okay, so how I would solve this. I've written it out already. How I would solve is by writing BEDMAS down the side so I can remember what my steps are. Okay, so brackets first. I have brackets over here. I'm going to take this guy. 7 times 3, 7, 14, 21. 21 is going to end up there. That's all the brackets I have in here. Okay, brackets done. Exponents. That's my next step. Exponents. I have that right here. So I'm going to do that next. 6 squared. 6 times 6 is 6, 12, 18, 24, 30, 36. Right there. 36. Okay. That's all my exponents done. Division. None of that. We can cross that right out. Multiplication. There is so much multiplication happening in here, but with all these numbers written all over the place and making things a little bit easier, we're going to rewrite the equation so we can see it. 4 times 3 plus 2 times 36 now. Excuse me. Minus 2 times 21 now. Okay, perfect. Now I can come in with my division, or my multiplication, sorry. We're on this step. And I know that first, I have to multiply. So I have to multiply this first, then I have to multiply this, and then I have to multiply this, and then I can add and subtract. So 4 times 3, 12, 2 times 36, 72, 2 times 21, 42. Awesome. Now that that's done, now I have addition, and I can see that here, but hard to see kind of because of all the writing, so I'll rewrite again. So I have 12 plus 72 minus 42. Now for my adding, I'll do that first. So 12 plus 72 is 84. 84 minus 42 is equal to 42. And that's our answer, right? So we did our addition and subtraction. Perfect. Okay, B. Variables. 2a minus 4b plus 3ab minus 5a plus 2b when a is equal to 3 and b is equal to 5. I'll pause here. There's definitely a little trick, but there's 2 ways you can do it. Okay, so you could, like we discussed, write in our variables in here, right? So this would be 3, this would be 5, 3 times 5, 3, 5, and calculate, add all it up in there, okay? And that is a great way to do it. Perfect. But the way I want to show you, it makes it a little bit simpler, okay? So I can actually take all of my like variables and subtract or add them together. So in here I have 2a and negative 5a, and I have negative 4b and 2b. So if we rewrite this with those together, I get 2a minus 5a minus 4b plus 2b plus 3ab. Now what I can do is notice, because these are the same, this is like taking just 2 minus 5 because they have the same variable. So I couldn't go 5 minus or 2 plus 2 because these two variables A and B are not the same. Same thing over here. If I had a 2AB, then I could add 2 and 3 together, but I don't. Okay, so we'll get rid of that. So what this is going to end up looking like after subtracting all this, so I had 2 minus 5A gives me a minus 3A, minus 4B, so minus 4 plus 2 is a minus 2B, because we don't want to forget that variable, and plus 3AB, because there was nothing else to add to it. Okay, so now I've super simplified this. And now I don't like having this negative up front, so I can rearrange again and I can make it go 3AB minus 2B minus 3A. Okay, so now I'm ready to go. This is when I'm going to sub in the values. So I have 3 times A, which is 3, times B, which is 5, minus 2 times B, which is 5, minus 3 times A, which is 3. Perfect. Now I can come in here with my precedence rules and check all this out. No brackets, no exponents, no division, but a bunch of multiplication. So again, I can throw in some brackets. So I'll do these ones, and this one, and this one. And then I'll also probably do this one. So in doing that, 3 times 3 is 9. And then I have 9 times 5 in brackets. Minus 2 times 5 is 10 in brackets. Minus 3 times 3 is 9. And I guess I don't really need these brackets here. And then I'll do this last step, 9 times 5. And 9 times 5 is 45. Minus 10. Minus 9 equals 26, yes. Okay, so in going back here, let's say we go back here, and I have 3 times 5. I could also do this one first, okay, because that'd be 3 times 15, which is also equal to 45. Okay, so it doesn't quite matter. There's again proof that it doesn't quite matter what order you do that multiplication in. Okay, so awesome. If you got 26, that's great. C. Another one with precedence. So I have 3 plus 2 squared minus 7. Okay, so take a moment there. Pause the video. Check this out on your own. Okay, so we'll hop right in. So I want to do those brackets first. Brackets first, always. 3 plus 2, 5. And now we have 5 squared minus 7. Exponents, always exponents second. 5 squared. 5 times 5 is 25. 25 minus 7 is equal to 18. And 18 is our answer. Nice and quick. D. 2 times 3 squared minus 5 squared. Okay, pause it, check it out, see how you did. Again, we'll start in those brackets. 2 times 3 is 6. Now I have 6 squared minus 5 squared. Exponents next. 6 squared is 36. 5 squared is 25. 36 minus 25 is what we're left with, which is equal to 11. Perfect. And one more on here before we do some reciprocal questions quickly. 6 squared minus 2 times 5 plus 1 plus 3. Pause the video, check that one out. Awesome. Okay, first we're going to start in these brackets. addition, which means we can kind of do it all at the same time. So I have 5 plus 1 is 6, plus 3 is 9. So I have 9 in the brackets there, so I can rewrite this as 6 squared minus 2 times 9. Exponents are next. 6 squared we know is 36. So I have 36 minus 2 times 9. Now we want to get that multiplication done. And we know that 2 times 9 is 18, so I have 36 minus 18, which is 18. And that's our answer. So great job if you got all of those right. If you only got a couple of right, maybe we need to go back and check out the video one more time. But first, let's try some reciprocal questions. So I want to know, and I'll write them all out quick, give you time to do them, and then I'll come back and do them. I want the reciprocal of 45 over 27, 1 over 22, 909, 20 over 35, and 12 over 32. Okay, so pause that, check that out. Remember those reciprocal rules. Okay, and here we go. So this one, remember when we have a fraction, we can just flip it. So it's 27 over 45. Same over here, we can flip it, which is 22 over 1 technically, which is just 22. Down here, we're just 1 over a whole number, so we have 1 over 909. For D, we have, again, a fraction, so we can just flip it, 35 over 20. And our last one, again, a fraction, and we can just flip it, or invert is another way to call it, 32 over 12. Okay, so again, awesome if you got all that right. If you didn't, maybe you want to watch the video again. There's lots of helpful hints in here, and I hope that you took a lot from it. I hope the questions were helpful, and I hope you enjoy the rest of your day. Thanks for hopping on and watching.